Okay, Amelia, hello. First question. You have a bit of a proof question and a second part that is, again, kind of a proof question, but not proof, yeah? So the first one, it says, if m and n are irrational numbers, where m is different than n, then mn, so the product, must be irrational. And we have to disprove this statement by means of a counterexample. I'm going to remind you, this is from year 12. Year 12, you learn 3 methods of proof. One of them is counterexample. We are going to always use counterexample to disprove something. So to prove that something is not always true. And we are just going to find a numerical example, and that would be enough. Yeah? Irrational numbers, I'm going to remind you, are the ones that we can write as a fraction. So any rational number is any number that we can write as a fraction. So that will be rational, and irrational will be one that we cannot write as a fraction. Can you tell me, any of you, or more than one you, who is saying you cannot see the question? What about everyone else? Can you see the question? You can see it? Okay, so Daniel, maybe is you. Maybe you want to leave the call and come back again. Maybe join again. You should see it. Everyone is yeah, looking again. Yeah. Sorry. An irrational is a number that cannot be written as a fraction. Do you have idea of any irrational number? Can someone name typical irrational numbers? Anyone? Would you tell me in the chat? Root 2. I have the roots. The roots that are not square numbers, they are going to be rational numbers. What else? Daniel, can you see now the screen? I hope you can. Yeah, amazing. Sometimes just leaving and coming back. More examples of irrational numbers. One famous one. Pi, and number e. So those are any root that is not a square number is going to be an irrational number. We cannot write a fraction with it. And pi, e are irrational numbers. So now, can you give me an example where I have two irrational numbers, but when I multiply, they become a rational number? Yeah, so I have to disprove this, which means I need m and n that are irrational, but mn is rational because they say it's also irrational. I am trying to disprove that. Yeah. Any examples? You have to think a tiny bit. Root 4, they say it's different. So Hamza, you are very close, but they must be different. And root 4 is rational because root 4 is 2. Root 3, root 12, that's a good one. Yeah, root 2, no, what did you say? Root 3, no? Root 3, root 12, they are both irrational. When I multiply them, I get root 36. And because 36 is a square number, that's rational. Yeah. So these two are rational. The product is rational. More? Any ideas? So any root 2, root 8, exactly, another one. So root 2 irrational, root 8 irrational, the product root 16 is 4. So you get the idea. You could, for example, do pi, multiply 1 over pi. Both of them are irrational, but when I cancel the pi's, will become 1 that is rational. Or 2 pi and pi. So as long as you cancel the pi, you will get a rational number. It's important that you remember what rational and irrational numbers are, mainly for the proof questions. Yeah, that's it. Just a numerical example. You don't have to give more than one. Yeah, they are not giving you more marks for doing more than one, just one. Then we have to sketch this graph. Do you remember all how to do modulus or absolute value of a function? Remember, everything that is below the x-axis becomes positive. So I mirror anything that is below the x-axis above. Yeah. So everyone try to represent that function and see what we are doing with that. So that's the first part. Some of you might have not seen this before. But if you have this function here, I'm going to start with that one, and then we add the 3. Y equals x, remember, is this straight line, yeah? The diagonal. When we do the magnitude, the absolute value there, the modulus, what I'm doing is mirroring everything that is below the x-axis above the x-axis, yeah? I'm just bringing this up. It's just mirroring. So this is absolute value of x, or modulus of x. What I'm doing when I'm adding 3, who can tell me? You unmute, you tell me in the chat what I'm doing when I'm doing plus 3. Up by 3, that's it, yeah? So I'm adding 3 means I'm moving up 3. So my, this function here is this one. So this is y modulus of x plus 3. I don't really need to represent the others. I just represent to explain, but if you don't have to do it in the exam, or if you do it in pencil so you can mark the other properly, yeah? That's the first part. Then explain why x plus 3, so this function is greater or equal than absolute value of x plus 3. So now we have the modulus around the x plus 3. How are we going to represent this function? Please try to represent it before I do it. So the same that before, if I have absolute value of x plus 3, I'm going to represent x plus 3, which is a straight line. It cuts in the 3, so this is the 3. So my function is doing something like this. But everything that is below the x-axis is going to be mirrored. Yeah, so I won't have this part here. I'm going to have only that. So I'm going to just change color so you can see what I'm doing. So this is the other function. So this is modulus of x plus 3. You see the difference between them both? They're completely different functions. So in one, I have the modulus, and then I move it up by 3. In this one, I have the modulus of x plus 3. So now, explain why this one, so the blue one, is greater or equal than x plus 3. The best thing to do is just represent the second one, because they don't ask you to represent the second one. They only ask you to represent the first one. But once you represent the first one, it's worth to represent the second one and just explain that for values of negative values of x, this one is always below. And for values of 0 or more, they are the same function. So you can say something like that. Yeah. For negative x, the function is below. For x or more, the function is the same. Yeah. And you can see that with the sketch, and that will be, it will give you the marks. Yeah. Let me show you the mark scheme, what they say. Yeah. So they do the sketch and they just explain that the graph is or the same or is above. Nothing else. You don't need to do anything else. No? It's clear? And it's clear how we represent the functions, both functions? Yeah, you can show me thumbs or you can ask me questions. Clear for everyone? Okay, this one. I know at this stage, some of you won't have seen differentiation from year 13, but what we are going to do is not too difficult. So bear with me unless we are going to try, because you will be able to do most of the question even if you haven't done differentiation yet. So we have this function. They give us the sketch, is 2e to the power of 3 sine x cos x between 0 and 2 pi. So they are stopping here and here. Then the curve intersects the x-axis at point R, which is this one, and we have to find the coordinates of R. Coordinates of R is just the root. Oh, sorry. It's just the root. So I'm going to make my function equal to 0. Yeah. Can we all make the function equal to 0? So this is the function, and this must be equal to 0. We are working in radians. Yeah, just when they give you the interval in radians, in terms of pi, we are going to work in radians. If you use the calculator, your calculator must be in radians. If we are adding 190 degrees, we are going to add pi instead. Yeah, so remember, we are working in radians. Oh, sorry. What are we? So what are we doing? We are making that equal to 0. So I have 2e to the 3 sine x cos x equals to 0. How am I going to make this function equal to 0? I have different factors. The only one that can be 0 is cos. Yeah, so e to the power of something never can be 0. Remember, the exponential has an asymptote in the 0. So e to the power of something never can be 0. So the only one that can be 0 is cos. Cos x is 0. If you remember, when x is 90 degrees, we are working in radians, so pi half. That's what the calculator is going to tell you. Is that my answer? Look at the sketch, because I did the mistake the first time I did this question. Is that my answer? Is this pi half 0? Who can tell me why that one is not? Ryan.
Because point of intersection before it, so you'd have to find the next solution.
Exactly, because it has not, they haven't given it a name. It's difficult to realize sometimes that you have another intersection first. So this first solution is this one. So we need to find the next one. We are working with cos. So the next solution is going to be 360 minus that one. 360 is 2 pi. So it's going to be 2 pi. This one is going to be 2 pi minus pi halves. Yeah, we are working like in degrees. Imagine you have degrees, you will have 360 minus 90 degrees. Yeah, it will be the same. Is 3 pi halves. No, that's 3 pi halves. So this point here is 3 pi halves. Careful with that. First time I did it, I just say pi halves. Everything is clear. So we just make this function equal to 0. Then the curve has two turning points, P and Q. You have them here. So P is a maximum, Q is a minimum. And we have to show that at points P and Q, this happens. Yeah, A, B, and C are integers to be found. So we have to, we will be able to find the points solving this equation, but at the moment they just ask us to find that equation. What are we going to do in general to find the stationary points? Can you tell me in the chat as briefly as you want? I will understand. What I'm going to do in general to find stationary points. So tell me in the chat, what would I do? Any question to find stationary points? Second derivative, it wouldn't be to find them. It wouldn't be to decide if they are maximums and minimums, Fraser. Yeah, that would help me to decide. Differentiate equal to 0. Exactly. So derivative equal to 0. I need to do f prime equal to 0. If you have done differentiation in year 13, can you try to differentiate this function, please? If you haven't, bear with me. So we have a product of two functions. Our trick is saying we are going to use the product rule. Exactly. So when we have two functions multiplied together, so if we have y equals a function multiplied by another function, the derivative is going to be the derivative of the first one multiplied by the second plus the first one multiplied by the derivative of the second. This is not in your formula booklet, so when you learn differentiation, you will need to remember this thing. Yeah. So what are we going to do? I'm going to call this u, for example. So all this is going to be u, and this is going to be v, and I'm going to apply that rule. But again, I'm differentiating a funny function, yeah, because I have an exponential to a function. I'm going to use the chain rule for that. So when I differentiate an exponential, I'm going to have at the front just the derivative of the exponent, yeah, and then the exponential the same. So I'm going to very carefully use the chain rule. So derivative of u, because it's an exponential with a function, I'm going to have 2 multiplied by the derivative of this one. Derivative of sine is cos, and it has a 3 at the front. So I have 2 times 3 times cos. 2 times 3 times cos. Don't worry too much if you haven't seen this at the school, because you will. Yeah, and you will see with me, my students, you will see with me. So 2 times 3 times cos, and then the exponential like it is, nothing changes. So e to the power of 3 sine x. That is only u prime. Now we multiply by v, which is cos x. So if you want, we can multiply by cos or just square this one. Yeah, I'm going to square it. That is just multiplying by cos. And then plus I'm going to keep the first one like it is and derivate the second one. This one, like it is, derivative of cos is minus sine. So I'm going to write a minus instead of a plus. 2e to the 3 sine x multiplied by sine x. Yeah? This must be equal to 0 to find the points of the stationary points. And now it's just a matter of writing the equation this way. So we want to write it all in sine. If this is equal to 0, yeah, if this is equal to 0, because e cannot be 0, yeah, if we factorize, you're going to see better if we factorize. So e to the power of something, remember, cannot be 0. We have done in the previous question. So if we factorize, we can factorize, well, we can put everything positive. I don't like those negatives. So I have 2e to the 3 sine x multiplying 3 cos square x plus what? Sine x equal to 0. And we have to write all in terms of sine, hopefully. Yeah. Yeah, so this bit cannot be 0. What is going to be 0 is this one. So this is equivalent to say that 3 cos squared x plus sine x is 0. And you know where we are going. What are we going to do? Substitute this by 1 minus sine squared. Yeah, and now everything is in sine. So I expand the bracket. So 3 times 1, 3. Or we can do one more step if you want. I don't want to get anyone confused. And now we expand the brackets and reorganize. So we have minus 3 sine squared x plus sine x plus 3 equals to 0. Yeah, I have expanded the bracket and reorganized a bit, and I'm going to change signs. So 3 sine squared x minus sine x minus 3 equals to 0. And that's my equation, yeah? That way, A, B, and C are going to be 3. So A is 3, B is minus 1, and C is minus 3. Yeah, I would write the constants. Did you get the same? The same coefficients? Everyone? Any question? The bit difficult here, I think, is differentiating this function. So it's a product, so product rule, and to derivate this function, we will need to use the chain rule. If you haven't learned it yet, you will learn it, and it will be clearer. Yeah, don't worry. Then, hence, find the coordinates of point Q, giving your answer to 3 decimal places. So we are going to have 2 stationary points. It's going to be this one here, yeah? So the second value that we find. Everyone solving this trigonometric equation, yeah? How I'm going to solve it? Who can tell me? This is C, no? Hidden quadratic, yeah, exactly. So I'm going to factorize that quadratic. So it's going to be 3 minus 1 minus 3. And I have sine x is going to be 1 plus root 37 divided by 6. And the same but negative. Do you get the same? George, tell me.
Is it not a positive sine x in the like quadratic?
In the quadratic?
Yeah.
So 3 positive minus 3. Yeah, you're right. So yeah, this is positive. But then I change all the signs, no?
Yeah, but in the like original thing you differentiated, wouldn't so the bit with the cos squared would be normal, but then the bit with the sine x would be a negative, like the second part of it.
You're right. So yeah, you're right. So this is, I don't know why I wrote this minus. So this is a plus and this is a minus, right?
Yeah, I think so.
And that means we have 3 cos squared and this would be a minus. Yeah, I think you're completely right. So this would be a minus. This would be minus, sorry everyone, minus, and this last one would be plus, no? Let me check the 3 plus and minus 3. 3 plus and minus 3. Yeah, you're completely right. Sorry. Thank you. Because now the numbers are going to look nicer than that. So 3, I have 3, positive 1, and minus 3. No, I still get something super dodgy. Do you get, so we have 3? No, yeah. So look, that's what we have to get. Yeah, so don't worry. The answers are going to be, so when we solve that quadratic equation, we get minus 1 plus minus root 37 over 6. No, that's what they get here. Yeah. The first solution is with the minus, and that would correspond to point P, right? The next solution is going to be the one with the plus. So that's the one we're going to get. So sine x is minus 1 plus root 37 divided by 6. We do sine minus 1 of that. In radians, so calculator in radians, if you don't have your calculator in radians, so sine minus 1 of minus 1 plus root 37 all divided by 6. And I get 1.1. Do you get 1.01? Yeah, and just that's the first solution, 1.01. So x is going to be, so we are ignoring this one because it's, okay, sorry, don't skip steps. So this gives us sine x minus 1 plus root 37 divided by 6, and sine x is minus 1 minus root 37 divided by 6. This is not giving me any answer because it's smaller than 1, remember? And sine x must be between minus 1 and 1. So this one, I'm ignoring it completely because it's smaller than minus 1. So this one, I ignore it. I keep the positive only. The first solution is 1001, and that's corresponding to this point. The next solution is the one that corresponds to Q. And the next solution, because I'm working with sine, is going to be the symmetrical in the vertical axis. Yeah, so it's going to be pi minus that, which is 2.13. Yeah, check if we have to round to anything in particular. 3 decimal places, so I'm going to keep 1 more decimal. Radians, and that's the one that corresponds to that point, to the second point. So this would be the first maximum, this would be the minimum. Question, I saw a hand going up. Aratrika, tell me.
Could you please re-explain why it's not the other one? Because I'm a bit confused.
Why is not this one?
Yes.
If you put this value in the calculator, you're going to see that it's smaller than minus 1. So minus 1 minus root 37 divided by 6 is minus 1 point something, is minus 1.18. And sine x is between 1 and minus 1. It cannot be minus 1.18.
Oh, okay.
If you don't realize, because seeing this number, maybe you don't realize that this is smaller than minus 1, when you use the calculator to find sine minus 1, you're going to get an error.
Okay.
That's why. Yeah, so we have, every time you have, it's like, remember those questions that suddenly you have sine x equals 2, and then you say, no, this cannot be. Is that? But the number is a bit more strange, so it's not easy to realize. Yeah, but that's fine.
Okay.
Yeah. More questions? No? Next then? Okay. Another one. Let me show you this one. So show that the expression, so we have sine to theta, cosec, cos to theta, and sec can be written this way. So only in terms of theta, although we have cos and sec. Yeah. So again, most of you, hopefully at this stage, will have seen the addition formulae and the double angle formulae. If you haven't, you have formulae that change sine to theta or cos to theta into just theta. Yeah, I'm going to remind you. If you don't have them there, you have sine 2 theta is to sine theta cos theta. And cos 2 theta can be written in different ways. Cos square theta minus sine square theta, or 2 cos square theta minus 1, or 1 minus sine square theta. They are not in the formula booklet, the double angle, but you will find sine of a plus b and cos of a plus b, so it's very easy to deduce them with that. Yeah. Okay. Please try to go from here to here before I do anything. Think what would you change? Think what can you simplify? Think that you want to keep the sec and all that. Because you have 3 options for the cos, sometimes it's worth it to think a tiny bit which one you want to use. If no, it doesn't matter. It's easy to change later. Yeah. So Amelia, what would you try? Substituting what? By what? Tell me.
Because the answer's in cos theta, would you try and get rid of the sine theta?
Yes, and because it's double angle and I have only angle, definitely I'm going to change this one by this. And what would you use for this one?
Would you make it 2 cos squared theta minus 1?
So this one?
Yes,
Let's try.
it's in.
Let's try it. Sometimes it's difficult to know beforehand, and it's okay. So we have sine 2 theta. I'm going to substitute by this one. So I have 2 sine cos, 2 sine theta cos theta. Then I still have this cosec. If you want, because we only have sec, we can write what cosec is. Yeah, cosec is the reciprocal of sine. So I'm going to write already that instead of cosec, I'm going to write reciprocal of sine. Because then this is going to cancel and I'm going to have 2 cos, and we are not very far from that, yeah? We have 4 cos. And now, instead of cos 2 theta, Amelia say she wants to try this one. We can try probably with any. Sometimes it's clear because you want everything in sine, you're going to use this one. Or everything in cos, you're going to use this one. But this question is quite mixed. So let's try this one. 2 cos squared minus 1. 2 cos squared minus 1. Multiply by sec. And I'm going to keep the sec because we need a sec. So let's go to see. Maybe we have to change it anyway. Yeah. What can we do now? We can cancel this. We have cos and sec. What do you think we can do? So this could be 2 cos. Still, it's very far from what we need. Ryan, what would you do?
If you turn the sec theta into 1 over cos theta, you can like split. It becomes a fraction, and then you can split it.
Exactly. This is going to be, even if it looks like I want to keep sec, maybe it's worth it to have it this way. So when I multiply this bracket, I have 1 over cos multiplying by 2 cos squared is going to be 2 cos theta. Yeah, because 1 cancels. And then when I multiply this by this, I again have my sec. Yeah, so minus sec theta. So I have 4 cos theta minus sec theta. Yeah, sometimes we need to play a bit. And if you decide to use a different one instead of this one, it still will work because we will be changing the sign into cos. Yeah, it's very easy to move between one and another. Is it clear? So that's the first bit. Sine theta different than 0 and cos theta different than 0. Always make a note on these things because they are not random. Yeah. Then the student is attempting to solve this equation. So the one that we have here equals to 3. Yeah. Between 0 and 360 degrees. They use the result from part A and write the following incorrect solution. So they change this thing here by this. So far it's okay, yeah? I would keep checking all the steps, but I recommend you to skip and check what they say is wrong. Yeah, so here they say, explain why the students should reject one of their values for cos theta in step 4. Because sometimes we are almost sure that there is a mistake, and we spend 5 minutes reading all the steps, thinking, where is the mistake, where is the mistake? And maybe in the questions they are telling you where the mistake is. Yeah, so don't waste time, just skip. Instead of reading the whole solution, see where the mistake is. So he does this, is all correct, yeah? And why should he reject one of the values here in step 4? So this one or this one? Which one and why? Can you tell me in the chat? Look at the restrictions here. They are for sine and cos. What is the problem? This one is very unlikely to be because it's a strange value. So if something happens, it's very likely to be with cos theta. What happens with when cos theta is 1? It's not this. Is it this one? It's going to be undefined, yeah? So when cos theta is 1, sec is going to be undefined, yeah? And it's because, and they tell you here, they say sine theta cannot be 0 because when sine theta is 0, cos is 1. Remember, when 1 is 0, the other is 1. So this one is the one that you have to reject because cos theta equals to 1 means that sine theta is 0, yeah? Because this happens when theta is 0. Yeah, that's the thing. So then state the correct solutions for this equation. So from these solutions, which ones are the correct one? We have them there. The only thing that we have to do is to discard which one, the 0 and the 360, because those are the ones that come from the cos theta equals to 1. Yeah, so my correct solutions are these ones. You don't have to do them because they are there. And you see that there is 1 mark, and when it's 1 mark, it's just a B mark, so you don't have to do any working out. You just can answer straight away. Does it make sense? Simple question. These questions sometimes require a bit of playing with different options because sometimes you don't know, do I substitute this one or not? Do I substitute this one or not? So sometimes you have to try a bit. More? Everyone's okay? Very quiet. This one. So someone asked me to do one of these ladders, rigid bodies questions. Yeah. So if you want me to do a particular question, just tell me and I'm happy to do any. So a ramp AB, length 8 meters and mass 20 kilograms, rests in equilibrium with the end A on rough horizontal ground. Rough horizontal ground, we are going to have friction on the ground. Yeah. Ramp rests on smooth, solid, cylindrical drum, so we don't have friction here, which is partly under the ground. You have the sketch, is helping you. AC is 5 meters, so we know this distance, and the ramp is resting in vertical plane perpendicular to the axis of the drum. Angle theta is this angle here, and the ramp is modeled as an uniform rod. So this is probably the most important information that we can get from there. Then we have to explain why the reaction from the drum on the ramp at point C acts in the direction which is perpendicular to the ramp. Yeah. First of all, I would like you to try to do the sketch. So copy the thing briefly and represent all the forces that you have acting, because these questions is important that you represent the forces in the correct direction on all of them. Yeah. So please think what forces you have and in which directions, and you draw them. Yeah. You just draw arrows. Does anyone want to help me? Ryan, would you help me to represent the forces? What would you represent?
At A, there would be a reaction going up, like vertically upwards, and then friction going like towards C on the ground.
Exactly. Why did you think towards C?
Because like when it's like balanced, it's kind of you're imagining it's going to start moving in the opposite direction to where the
Mm.
balance is.
Exactly. So if this is super slippery, imagine this is ice, the bar will slip that way. Yeah. So the friction goes always against the direction of motion or the tendency of motion. So I would recommend you think is ice and what will happen with the bar. Yeah. What else? Perfect.
4 meters along the bar, there'll be 20 G acting downwards.
Exactly. The weight, it looks like it's perpendicular to the, is here. So 20 G, that's the weight. Yeah, this is the midpoint. What else? One more.
There'll be a reaction force at C, and I think it'll be going like diagonally, like perpendicular to AB.
Perpendicular to AB. And in fact, they asked you why is perpendicular to AB. Perfect. So those are all the forces that we have. Yeah, always perpendicular to the ground. I will have a normal reaction wherever I have. So if this is a bar, but the typical question of a ladder against the wall, I'm going to have perpendicular to the ground, perpendicular to the wall. Yeah, normal reactions. Then friction, because it's rough and it's precisely what is stopping it from slipping down. The weight in the middle, because they say is uniform rod. And we are going to have a normal reaction here and no friction. We could have friction here, but they say smooth. Yeah. Why is this perpendicular? It's perpendicular to the bar, but not because must be perpendicular to the bar. Remember, it's perpendicular to the surface. So here is perpendicular to the surface. Here is perpendicular to the surface. So in a circle, if I have a tangent, the normal is perpendicular to the tangent. And that's why, yeah? So this is not perpendicular to the bar because it's perpendicular to the bar. It's because it's perpendicular to the surface of the cylinder. So it must be radial. Does it make sense? That's why. Let me show you what they explain. There is no friction. The front reaction is perpendicular to the ramp, yeah? Because it's perpendicular to the, to this cylinder, yeah? Then, this is the big one. Look, 9 marks. Find the magnitude of the resultant force acting on the ramp at A. So we need the resultant force at A, this one. Yeah? This is a moments question, so we are going to be taking moments. Remember, when I have a rigid body in equilibrium, 2 things happen. The resultant moment about any point is going to be 0, and the force about any point in any direction is going to be 0. So this allows me to write equations vertical and horizontal. For example, forces pointing up equal to forces pointing down, like in a particle, or forces pointing right equal to forces pointing left. And this one, the equations are going to be more difficult because I have to include distances, but I will need to do one of those equations 100%. So the first thing we have to do, because we have forces vertical and horizontal, is to find the components of this force vertical and horizontal. So they are all in 2 main directions. And remember, I'm going to do that just using simple trigonometry. I want to find the components of this vector in 2 directions. Yeah? This angle is going to be equal to this angle. So if this is theta, find the clock. Yeah, exactly. Electrical, but I'm going to do that after I find the components of the forces. So this one is theta as well. If you look at this right angle triangle, this is adjacent to the angle and the hypotenuse is RC. So this component is going to be RC cos theta. So the other one, this one here, is RC sine theta. Yeah, I'm just using trigonometry. If this is theta and this is the hypotenuse, this is A sine theta, this is A cos theta. Yeah, just that. Now, if I use sum of forces vertical, these 2 together are going to be equal to this one, but that doesn't help me too much at this stage. And the friction to the right is going to be equal to this one to the left. So again, it's not going to help me too much. I'm going to take moments. We can take moments about any point. If you want to find this force, you will be thinking, okay, I'm not going to take moments about A because then RA won't be in my equation. Remember, if I take moments about one point, the forces passing that point, the moment is going to be 0. But I don't want to find the friction. and I don't have enough information to find the friction. They don't give me a coefficient of friction. It will be too many equations. So what I'm going to do is to take moments about A. RA won't be in my equation, but it will allow me to find RC, for example. Yeah. With RC, I will be able to find RA. That's not uncommon. Yeah. So if we don't have enough information to find the friction, I can take moments about A and then find RA somehow else. Yeah. Let's go into that. At trick I said, we have to decide we have to find the clockwise moment and the anti-clockwise moment. Yeah. About A, this force is producing a clockwise moment. You see, I move in the direction of the force. This is going to be clockwise moment. And again, about A, this one is producing an anti-clockwise moment. Yeah, so I have one clock, one anti-clock. So they are going to be equal to each other because this is in equilibrium. The clockwise is going to be equal to the anti-clockwise. Let's go to find that. I don't know what to do it, so we keep an eye on the drawing. So the clockwise moment, I'm going to take moments about A and must be 0. So the clockwise moment is going to be equal to the anti-clockwise moment. This one, the clockwise moment is going to be the force, so 20g, multiplied by the perpendicular distance from the point to the line of the force. Perpendicular distance from the point to the line of the force. So look here. You see this right angle triangle? Perpendicular distance from here to here is this one. So I need to find this side. We know this is 4 because the bar is 5 and this is the midpoint. So this is 4 and this is adjacent to the angle. So this side is going to be 4 cos theta. Yeah, this distance is 4 cos theta. So multiply by 4 cos theta. That's the clockwise moment. What is the anti-clockwise moment? Who can tell me? Tracer.
Would it be 5 multiplied by r cos theta?
Almost. Perpendicular distance. I know it looks like is that, but perpendicular distance from A to the line of the force. This is the line.
Oh
of
yeah,
the
it can't be that.
So 5 multiplied by. That's the force. I don't need to use this one. So
Oh, just RC.
Yeah, RC, exactly. Yeah, do you see why? Is the force multiplied by the perpendicular distance. So it's going to be RC multiplied by 5. I don't need the components at this stage. Yeah, I can do RC multiplied by 5. So equals to RC multiplied by 5. Cos theta, we have it because we have the angle. Yeah, the angle, they give you tan theta. So if this is theta, tan is 7 over 24. If you do Pythagoras, this is going to be 25. So cos theta is 24 over 25. Yeah? So this is 24 over 25. And from here, I can find RC. RC is going to be what? No. I get 150.5. Did you get that? Yeah, 150.45 newtons. That's RC, but that's not what I need. Yeah, this is RC. I need RA. How can I find RA? I can resolve vertically. Yeah, because I know I have vertical equilibrium, resolving forces vertically. Exactly. So if I resolve, first I took moments about A, now I'm going to resolve vertically. So forces pointing up are going to be equal to all the forces pointing down. Pointing up, I have RA plus RC cos. Now I'm using this one because I'm working vertical completely. Yeah. So RA plus RC cos is going to be equal to the only force that I have down, which is this one. Yeah. So RA plus RC cos RA plus RC cos, which are pointing up, is going to be equal to the only force pointing down, that is the 20G. So RA is going to be 20G minus RC, that was 150.5 newtons, times cos, that was again 24 over 25. Yeah. So this is 51.5 newtons. Yeah. And wait a minute, because this is not what they're asking. I just realized they are saying not the normal reaction, the resultant force, not the normal reaction. The resultant force acting on the ramp at A. What does that mean? I read the normal reaction, but it's not the normal reaction, it's the resultant force. What are they asking me? Anyone? Come on, don't be shy. I know many of you are thinking and you don't want to say. What happens at A? The vectors, I combining the vectors, exactly. So at A, I have a force pointing up and a friction pointing to the right. My resultant force is just going to be the combination of these two. Yeah, so I will have a force pointing that way that is going to be the resultant force at A that they are asking me. Yeah, so I have this one, I just found it. I need this one because then I will do Pythagoras and find this one. How am I going to find this one? Can you tell me in the chat? How do you think I can find the missing friction here? I don't have the coefficient of friction, so I won't be able to find that way. How am I going to find the friction? Exactly, resolving horizontally. Now I'm going to do resolving horizontally. And that's the last thing. That's why it's 9 marks. So forces pointing to the right is only the friction. Forces pointing to the left, RC sine. So friction to the right equal to friction force to the left. Yeah. So the friction is going to be the 150.5 that we found before, multiplied by sine. If you look at this triangle, sine theta is 7 over 25. Yeah. So multiply by 7 over 25. This one is 150.5 times 7. If you haven't seen this at the school, you will be wanting to kill yourself. This is very difficult if you haven't seen it. Yeah, when you see it, you will start to understand. But we are mixing rigid bodies, moments, and forces that we did in year 12. Yeah, it's really a mix and it's not easy, but you will, when you see it at the school, it will be clear. Don't worry. So what do we have here? We have 42 point something and 50 point something. So we are going to find the resultant force just using Pythagoras. Yeah, so I have a 42.1 to the right, 51.5 up, and I'm just looking for this resultant force. Yeah, so F is going to be square root of 51.5 squared plus 42.1 squared, and that is 66.5 newtons. They are asking the magnitude. Yeah, so look for these things, because if they say find the force, we will be given the components. Yeah, that force, if we give the vector, it will be, look, if they ask me the force, I will have to say 42.1 to the right plus 51.5 up. Yeah, or if you prefer the other notation, 42.1, 51.5. Does it make sense? Because they say magnitude, I find the magnitude of the vector. That's the only thing I'm doing. Yeah. So this is the question. Was it too complicated for those who haven't seen this? Surely yes. Okay, I hope it was okay. If not, because you are going to have the recording You can rewatch it when you see this topic. Then the ramp is still in equilibrium in the position, so where it's still the same, but the ramp is now not uniform. So uniform rod, we put the weight in the middle. If it's not uniform, it will be somewhere else. It says, given that the center of mass of the ramp is assumed to be closer to A than to B, so this weight was in the middle, but the center of mass is now closer to A. So this weight is closer to A now, yeah? And it says, state how this would affect the magnitude of the normal reaction between the ramp and the drum. So this one, it's just 1 mark, so it's a big one. You just have to give, if it's increasing, if it's going to be higher or lower, that's it. You don't even have to explain because they don't say giving reasons. What do you think? If I move this way to the left, what is going to happen with this one? Is going to be greater or smaller? Can you tell me in the chat? So it's going to be greater or smaller? Smaller. What about everyone else? Smaller, too smaller. Everyone else? Yeah, exactly. It's going to be smaller. You almost can see by logic. Yeah. So if you bring this one here, the force here is going to be more, and this one is going to feel lighter. But think that we find this one using moments, and the moment for the same force, if this distance is greater, the moment is going to be greater. Yeah. So yeah, it's going to be smaller. Any question? No? Okay, next one is going to be easier. So we have a few more minutes, so let's go into do one more. Yeah, it's a proof question. By contradiction. So you learn proof by exhaustion, proof by deduction, and proof by counterexample in year 12, and you learn proof by contradiction in year 13. Some questions won't tell you what method to use. It's up to you. Some questions will, like this one. Do you all remember how we do proof by contradiction? Sort of. We have to start writing the opposite to what we want to prove. Then we start to do some working out. We find a contradiction, and because we find a contradiction, what we are trying to prove is not true, so the original statement is true. Yeah? So what are we going to write first? We are going to write the opposite. So I'm trying to prove that this is irrational. Yeah? So what I'm going to write that I'm going to try to prove exactly that is rational. Yeah. So what I'm going to say is that cube root of 2 is rational. And then I will see that is a contradiction. Yeah. If it's rational, remember what we did at the beginning with rational numbers? I say, if it's rational, that means I can write it as a fraction. And the trick, I don't know if you remember the proof of root 2 is irrational, because we are going to do exactly the same. So I hope if you have seen this proof, you remember. If this is rational, I'm going to write as a fraction. So I'm going to write it as an A over B. Does anyone remember what was the trick? What do I assume, apart that I can write it as an A over B, that is going to help me to do the proof? Anatrika, you remember? Tell me what I'm going to
Do we
assume.
cross multiply and say, like, it's a multiple of cube root of root 2? Cube root of 2.
It's a multiple. do you
Or is
mean?
it a factor? I kind of forgot.
It's something about this fraction. How is this fraction? Can someone remember? It's in the simplest form. I know it's difficult to remember. It's in the simplest form. Yeah, this fraction has the A and B has no factor in common. Yeah, in the simplest form, and we can assume that in the simplest form. Please remember, because it's the way of proving this, or root 3 or root cubed. Yeah, we are doing all these questions in the same way. It's in the simplest form. So now we start our working out, and at one point we are going to discover a contradiction. What would be the working out? Probably cubing both things. So if I cube both things, I have this. Yeah. So if I cube both sides, I will have this. That could mean that a cubed can be written as 2b cubed. And that will mean that a cubed is what type of number? A cubed, if it's 2 times something, is even, right? Because I can write it as 2 times something, a cubed is even. This means, and you should remember, it's not difficult to prove, but you don't have to prove it, that a is even. The same that when it's squared. So if a number squared is even, that means that the number is even. You can remember that, and you don't have to prove it. It's very easy to prove. If we can do one day, we can in a lesson we can do it. Yeah, we can prove by contradiction very easily. A cubed is even. That means that a is even. Now, if a is even, that means because a is even, I can write a as 2n, for example. Yeah. If I go back here or here, a cubed is going to be 2n cubed. Yeah. And I know this is 2b cubed. I'm just going back here with my a even number. So that means 8n cubed is 2b cubed. So that means that b cubed, I hope you see where we are going, is 4n cubed. That means what? B cubed is even, again, is even. And because b cubed is even, b is even. What is the contradiction? If a is even and b is even, this fraction is not in the simplest form, yeah, because we could divide both of them by 2. What are you writing now? This is a contradiction because that would mean, I'm not going to write everything, but please listen what I'm saying, yeah? This is a contradiction because if a and b are even, this fraction is not in the simplest form, which means a cube root of 2 is not rational and therefore is irrational. That's what you are trying to prove, yeah? So please always remember to write the opposite to what you want to prove. Start to do some working out until you reach a contradiction. That's why it's proved by contradiction. And then you write a conclusion. What is the conclusion? This is a contradiction. Therefore, this statement that I'm trying to prove is wrong. Therefore, the original one, the one that I'm supposed to prove, is the one that is correct. Yeah? Is it clear? Do you have any question? Do you want to use a couple of minutes to prove this thing? I'm going to show you how quick that is. Let me show you. If you don't have any question, let me show you that. So a squared even, I'm going to prove that a is even. Yeah? You don't have to prove it in the questions. You can know that. Yeah? So you can just say because a squared is even, a is even. Or because a cubed is even, a is even. Let me show you the marker scheme. Look. B cubed is even, a cubed is even, that means a is even. You can just write that straight away. Yeah? Let me show you how very quickly, if you have a couple of minutes. We are going to prove by contradiction, which means I'm going to think about the opposite. So instead of even, my contradiction is going to be that this is odd. Yeah? Please don't do both, because then both will be true. Yeah? Or might be true. Just one. You just write the opposite to 1. So I'm going to suppose there is I can say there is an a that is odd, such as a squared is even. That's what I'm trying to prove. That's the equivalent to this one. Yeah, the one that is not true, and I'm going to find the contradiction. Yeah, so a is odd, such as a squared is even. If a is odd, that means I can write it this way. What happens with a squared? A squared is going to be 2n plus 1 squared. So 4n squared plus 4n plus 1, which is 2n squared plus 2n plus 1. This is even, but when I add the plus 1, it's going to be odd. Yeah, and I have assumed that this will be even. That's your contradiction. And because there is a contradiction, this is not true, and this was true. It takes very, very little. You would do the same for the cube. So a is odd, such as a cubed is even. You do the cube of this number, you're going to have a +1, and it's not going to be even. Yeah. It's proof by contradiction. It requires a bit of practice, mainly to write this statement. You have to think carefully, what are you saying no to? And then start to work, because then you will find the contradiction. Yeah. And I would recommend you for these rational numbers, because it's not an uncommon proof, just remember the trick. When we are proving that a number is rational or irrational, what we are doing is making it equal to a fraction, but we are going to say always that this is in the simplest form. Yeah, because then the contradiction is because this is not in the simplest form. We are going to find out that both numbers are always even. Yeah. Any question? No? If you are proving √3, instead of being odd or even, the numbers will be multiples of 3 or non-multiples of 3. So it works in a similar way. If you have one day and you are interested, just try. And if you cannot do it, you tell me. Any question? No? For those who I don't see regularly, on next Sunday, so not tomorrow, the Sunday after, I'm doing a little webinar to give you ideas of how to improve your grades over the holidays, just to make the best out of the holidays. It will be on Sunday 14th at 10 a.m. It will be like half an hour, and I'm going to give you some recommendations to use the holidays. Yeah. Okay, if you don't have any question, see you soon, and some of you have reset. Bye-bye.
Thank you so much.
Bye.
Bye.
Thank you.
Bye.
Thank you.
Bye.